Good morning everyone. My name is Pooja M. I am from batch 8. My seminar topic is real-time face detection and tracking using OpenCV. Now let me start with the introduction. Face detection is a computer technology that determines the location and size of human faces in arbitrary images. Arbitrary images are nothing but digital images. Digitally captured images are known as digital images. It detects facial features and ignores anything else. Example, building, trees, bodies. Other than human face, it will ignore all the surrounding environment. Human face perception is currently an active research area in the computer vision community. Human face localization and detection is often the first step in applications such as video surveillance, human computer interface, face recognition, as well as image database management. Locating and tracking human faces is a prerequisite for face recognition and facial expression analysis, although it is often assumed that a normalized face image is available. Objective: we intend to implement a real-time face detection and tracking the head poses position from high-definition video, that is by using HAR classifier algorithm. Here we use Raspberry Pi BCM 2835 CPU processor, which is combination of SoC with GPU based architecture. Here we are using two libraries, SimpleCV and OpenCV, which are used for face detection and tracking the head poses position. The experimental result computed by using computer vision, SimpleCV and OpenCV framework libraries along with the above mentioned hardware results with obtained by using 1080 resolutions for high accuracy and to increase the speed for the detecting face and tracking the head poses position. Area of the project. The project is implemented on the IoT platform. The software and hardware requirements are as follows. The software requirements: OpenCV 2.3.1 Super Pack for Windows, Raspberry Pi operating system, etc. Hardware requirements: PC preferably running Windows, Raspberry Pi 3, that is model B, standard servers, webcams and USB interface, some general breadboards, jump wires, hobby wire. Hobby wire is used to tie the pan, or it is also used to tilt the servers as well as webcam together. Breadboard is generally used to make the connections. Here I am using servos. A servo motor is a rotatory actuator or a linear actuator that allows for a precise control of angular or linear position, velocity and acceleration. It consists of a suitable motor coupled to a sensor for position feedback. Webcam. I am using a webcam and a USB interface. The webcam's USB goes to the PC. The code will identify its via a number representing the USB port and its connections. Methodology. The tools and methodology to implement and evaluate a face detection and tracking using OpenCV are detailed. OpenCV, Open Source Computer Vision Library. It is a library of programming functions mainly aimed at real-time computer vision developed by Intel. The library is a cross-platform. It focuses mainly on real-time image processing. The library was originally written in C, and this C interface makes OpenCV portable to some specific platforms such as digital signal processors. OpenCV includes both its traditional C interface as well as new C++ interface. The new interface seeks to reduce the number of lines of code necessary to code up vision functionality as well as reduce number of common programming errors such as memory leaks, etc. that can be arised when we are using OpenCV in C. Most of the new developments and algorithms in OpenCV are now developed in C++ interface because it is difficult to provide a wrappers in other languages to C++ code as opposed to C code. Therefore, the other language wrappers are generally lacking some of the new OpenCV 2.0 features so that it can be easy to write a wrapper in other code. Now let me explain this diagram. The function of the face detection module is to clarify whether the face is available during the real-time monitoring for detection or not. Here first there are two cases. First case is your image is enrolled, your image is not enrolled. If your image is enrolled, then your image will be captured for verification and identification. Then the face detection processing will be done. If any feature, it will extract the features. If any match is found, result will be displayed. Else verification and identification will be failed. If your face is not enrolled, then user face is captured and it is extracted. The extracted image will be stored in the template database. Then the process will repeat. The face detection is done by scanning up an image for different scales and looking for some simple patterns. When the system detects the face, it will produce a sub-image, and this sub-image is scaled such that the face appears in the center and it should be in a uniform size. OpenCV already provided an algorithm to locate still images as well as video streams. HAR classifier algorithm scans the image and creates a bounding box as written for each detected face. Decision tree based on HAR-like features, that is cascading form. Face detection determines where in an image a face is located, and it is being done by scanning the different image scales and extracting the exact patterns to detect the face. The prototype is built with HAR-like features functions from OpenCV. Here we may consider multiple features, for example eye retina size, nose size, lip size, etc. Let's consider eye retina size as feature 1. If the feature 1 matches, then it will check for feature 2, so on it will check for n features. If everything is matched, then it will return true, else it will return false. Benefits to the organization. Robust and real-time face detection plays a vital role in many of the application scenarios like biometrics, and it is used for facial recognition system. It is also used in video surveillance, human-computer interface, image database management, as I said before. Some recent digital cameras use face detection for autofocusing. Face detection is also useful for selecting the regions of interest in photo slideshows that use a pan and scale Ken-Burns effect. Face detection is gaining the interest of marketers. A webcam can be integrated into a television and detect any face that walks by. The system then calculates the race, gender, age. Once the information is collected, a series of advertisements can be played towards that specific detected race, gender, age, face, etc. This also shows prototype or partial implementation of this type of work. Face detection is also being researched in the area of energy conservation. Future scope. The proposed system can be further applied to the rotated faces as well as to detect and recognize the faces in speed videos, very speed videos. The proposed system can be extended to analyze very minute facial expressions without missing any of the expression. Conclusion. The face detection and tracking is being a challenge for many researchers with real-time image sensor. With the advancement, the real-time face detection in the remote monitoring is helping for building many efficient industrial and commercial applications. Moreover, such technologies can be useful in tracking the lost objects under dynamic environment. Further enhancement of this work can be extended with stereo depth analysis of face detection by using two image sensors, which can be interfaced with high-speed processors. Here are the few IEEE papers which I referred from for this seminar topic. Thank you everyone.